Okay, today we're going to go over some of the terms that we use when we talk about characteristics of hominins versus non-hominin apes. So I have 5 skulls here. One is from a modern ape, and then the other 4 are from ancient hominins. And then of course I have a modern hominin present as well, because I have a nice skull here. But first let's talk about the features that are associated with the ape-like creatures, okay? Things that identify them as more ape-like than hominin-like. The first one we're going to talk about is the obvious. For the ape, has a lot of different robust features. One of the more noticeable ones is this little ridge up here. We call that a sagittal crest, okay? And the ridge back here is called a nuchal crest. These crests are places where muscles attach. The gorilla, which is what this skull is from, has very large muscles that attach to the jaw and allow it to process very, very tough leaves that it eats. And so the muscles will go up through the zygomatics and attach on the crest, the sagittal crest and the nuchal crest. Speaking of the zygomatics, you can see that the zygomatics on an ape are very, very flaring. They're very broad. That's to allow those large muscles to go up through and attach. There is a characteristic on the skull that can differentiate between a hominin versus a non-bipedal ape. And that is the foramen magnum, which is the hole where the spinal cord goes up into the brain. In an ape that's quadrupedal, that spinal cord hole is oriented at the back of the skull, so that the spinal cord is going up into the skull at an angle like this, so that they can be comfortable walking on all fours. When you become a biped, that little hole, the foramen magnum, is going to be more centrally located underneath the weight of your skull. So it moves forward in the skull so that you're more comfortable and the spinal cord goes up into the brain at a more upright posture. And as we look at all of the hominins that we have here, all of their foramen magnums are actually more forward placed than the ape. As you become more modern, we have a more modern location of that foramen magnum. Okay, across the top of the eyes, we have another ridge. This one's called a supraorbital torus. And like the other 2 crests that we talked about, this will reduce in size as we become more hominin-like. In profile, the gorilla here has a noticeable snout. We call that subnasal prognathism. Prognathism just means sticking out, and subnasal would be below the nose. You probably also notice that the gorilla has some fairly large canine teeth. We call this a canine complex, and some of our earliest ancestors also had a canine complex. When you have large teeth like this, you have to have a space for those teeth to settle in when you close your mouth. And we call that a diastema, and that's associated with that canine complex. And in some of our earlier ancestors, you will see remnants of a diastema associated with the canine complex. Okay, so needless to say, the size of the brain is going to become smaller and smaller as well as in the ape's side. It's going to become larger and larger in the hominin side. So a gorilla, even though it has a massive skull, has a very small brain, about the size of my fist. If we take a look at one of our earliest ancestors, this is Australopithecus africanus. The brain size is comparable, even though the skull size is much smaller. You'll notice that by the time we have Australopithecus africanus, which was a bipedal ape, a hominin, we have lost the sagittal crest, we've lost the nuchal crest, we've reduced the supraorbital torus, but it's still present. We've also reduced the zygomatics, even though they're still fairly large compared to our modern zygomatics. Australopithecus africanus also has a little bit of a snout, but it seems to have lost its canine complex. It has much more human-like teeth. When you compare it to the ape, some things are still more ape-like, some things are more human-like. When we look at the size of the brain, another thing that we look at is what we call a postorbital constriction. And that's a little area behind the eyes that's reduced in size. It sort of constricts just before it gets to that supraorbital torus in both of these apes. Okay, we're going to look at an anomaly in our evolutionary past. This is actually a descendant of some of the earlier hominins that lacked the ridges that other apes had. But they re-evolved the sagittal crest here. They re-evolved some of the nuchal crest, and they have much larger zygomatics than their counterpart, the Australopithecus africanus. They still have about the same size of brain. They still have the postorbital constriction. They still have some very large brow ridges. Their teeth are slightly larger as well. But again, they don't have that canine complex. The teeth that are larger are these molars. This particular species, Paranthropus boisei, is known as an offshoot that specialized in leaves and foliage as its food. And the particular types of leaves and foliage that it chewed on required very large muscles. And so it evolved to have a new nuchal crest a sagittal crest similar to the gorillas to hold those muscles. Okay. Again, it has a little bit of a subnasal prognathism, a little bit of a snout there. Okay. We'll compare this to a more modern hominin. This is Homo erectus. Okay, Homo erectus, even though it doesn't have a lot of the characteristics that we just talked about, has a much larger brain. Still has a little bit of postorbital constriction going on. Has a little bit of a brow ridge. Okay, it does not have a sagittal crest. However, this skull cast comes from the Homo erectus mojocertensis, which is the eastern variety, and they have a little, what we call a sagittal keel. Okay, a little bit of a ridge across the top that doesn't rise to the size of a crest. We also have what we call parasagittal depressions on either side of it that sort of accentuate that. Okay, it's believed that this was used for chewing some rough foliage as well, but not to the extent of the Paranthropus boisei. Okay, the zygomatics are more reduced. Okay, we have less robust features, and again, that larger brain. Then we come to one of our ancestors that had the largest brain of any human form. This is the Homo sapiens neanderthalensis, the Neanderthal. And their brain was slightly larger on average than the modern population of modern humans, Homo sapiens sapiens. Many of us still have some DNA from the Neanderthals, which indicates that they technically are the same species. They were just a subspecies of us. They were able to reproduce with us and produce offspring. When we look at the size of the brain compared to the Homo erectus, it's much larger. The zygomatics are much more reduced, more human-like, more modern human-like. They're slightly larger than ours, but they're not outside of our range of variation. They also have a little bit of what we call brow ridges. This is sort of the remnant of the supraorbital torus. Some of us in the modern population have brow ridges, a little bit of a brow ridge, but we have more of a forehead that doesn't slant back. So even though they had a larger brain, it was organized a little bit differently. The vault, the cranial vault, was lower than our modern cranial vaults. If you look at my forehead, for example, I have a very tall forehead compared to a Neanderthal. Their teeth were slightly larger than ours. And one major thing that we can tell about us, how we can tell that these ancient folks were not fully modern humans, other than of course the brow ridges and things like that, is that none of these have a noticeable chin. So just like the gorilla, the chin slopes back and there's no little bump in the front that is a modern human chin. So you look at that, it slopes from the teeth back, slopes from the teeth back, slopes from the teeth back, and slopes from the teeth back. If you look at my chin, it does not slope from the teeth back. I have a little bump there. Okay, that's one of the characteristics, other than being less robust than any of these other creatures, that makes me a modern human, a Homo sapiens sapiens.